Let's take a look at the process of applying polynomial division to the rational expression 4x cubed minus 28x plus 15 over x plus 3. So I'd like to divide the polynomial in the numerator. I'd like to divide that by x plus 3. One technique that we can use is long division. If I write x plus 3 on the outside of a division bracket and write the other polynomial on the inside, including a 0 for the x squared term, which is missing from the numerator, then the process of division is very similar to division with numbers. I want to think about how many times the x plus 3 can go into this expression, and specifically how many times x can go into 4x cubed. Another way to think about that is, what can I multiply x by to turn it into 4x cubed? Well, I can multiply by 4x squared. So then we want to take that 4x squared and multiply x plus 3 by it. That gives us 4x cubed plus 12x squared. So I want to subtract 4x cubed plus 12x squared from the given polynomial, from the dividend. We chose 4x squared because it makes the 4x cubes cancel, subtracting 4x cubed from 4x cubed. And then I want to be careful, I want to subtract the 12x squared, so that becomes a negative 12x squared. Because we're taking it away from 0, the term that wasn't present in the original expression. And then I can bring down the negative 28x and think about, how can I turn x plus 3 into something that looks like negative 12x squared? Well, I can multiply by negative 12x. Multiplying the entire expression by negative 12x, multiplying the entire divisor by negative 12x, gives me negative 12x squared minus 36x, negative 12x squared minus 36x, and now I want to subtract that from the expression up above. So the negative 12x squareds, again, we chose negative 12x so that it would match, and those cancel out completely. Subtracting negative 36 from negative 28 gives me a positive x. We can bring down the 15, so I get a plus 15. And then the last step of our problem, I can multiply by 8 to turn x plus 3 as much as I can into 8x plus 15. So I get 8 times x plus 3 gives me 8x plus 24, and I want to subtract. So subtracting 24 from 15 gives me a negative 9. And we have our answer, where this expression is called the quotient, and this, of course, is the remainder. We started here, I'll call this the dividend. And a nice way, there are a couple nice ways to write the final answer. One form for the final answer would be q of x plus r of x over d of x. So that expression is actually perfectly equivalent to the original rational expression that we started with, but it highlights the quotient, 4x squared minus 12x plus 8, and then we add on to that the remainder, minus 9, divided by the divisor, x plus 3. So that's one way we can present our final answer. Another nice way to present the final answer is by thinking of, the numerator. I could call this p of x. This is called the dividend, the thing that we divided into. That p of x, it's actually equal to the divisor times the quotient plus the remainder. So these two forms, they're related. If I think about taking this expression and multiplying everything by the divisor, we get this. The divisor times the quotient, and then multiplying the rational expression by the divisor, it cancels out the divisor and leaves us with the remainder. So the original p of x, the numerator of the original rational expression, it's actually equal to x plus 3 times the quotient that we found, 4x squared minus 12x plus 8, and then minus 9, just minus the number remainder. And what's nice about that form, one thing that we can see from that form is that if I plug in negative 3 for x, that's going to make this part of the expression become 0, so that makes the entire part here, that the quotient times the divisor, equal to 0. And so we can see from this form that p of negative 3, the value of that numerator polynomial, the value of the dividend at negative 3, has to equal the remainder. That fact is called the remainder theorem. If we divide by something that looks like x minus c, then the remainder equals p of c. So since we divided by x plus 3, the value of c would be negative 3, and we were able, from the remainder, negative 9, to find the value at negative 3, the value of the numerator expression. I hope you enjoyed the video. Thanks for watching.